second class, starting a new chapter, another 8th grade standard, real numbers and Pythagorean. So our first lesson here, 14.1, we're going to talk about square roots. Let's look at some key ideas. When you multiply a number by itself, you square the number. The symbol for squaring is the exponent 2. So our example, 7 squared. What that means is you're multiplying that number 7 by itself twice. So what this really means is we're doing 7 times 7, which equals 49. The number 0, I just want to look at this note real quick, has only one square root, and that is 0. So what I mean by square root, so we undo squaring a number. So the inverse of squaring is to take the square root of a number. That's the opposite. Just like if we were multiplying a number to undo multiplication, we would divide. Same thing here, if we're squaring a number, to get rid of that, we would take the square root. So the symbol for squaring, or for square root, is this radical sign, which looks like this. So if I was to take the square root of 49, you're thinking, what number do I multiply together to get 49? And we just did it up here. It would be 7. Some other vocab. A square root of a number is a number that when multiplied by itself equals the given number. Every positive number has a positive and a negative square root. A perfect square is a number with integers as its square root. So like the square root of 49, that's a perfect square. 7 is its whole number, that's an integer. So the symbol, again, looks like this. That's the radical sign. It is used to represent the square root. The number under the radical sign is called the radicand. So 49 in this case is the radicand. All right, let's take a look. So we can have positive square roots, negative, and then both positive and negative square roots. So a positive square root is just that normal looking square root. I drew an example right there. So if I were to take the square root of 16, what number do I multiply together to get 16? That would be 4. But what if I take the negative square root of 16? Well, the square root of 16 is 4, but I have to carry that negative through. So my answer would be negative 4. And what if I want to take the positive and negative square root of 16? That means my answer would be positive and negative 4. Let's do some examples. First example, find the square root of a perfect square. So what are the two square roots of 49? Now remember, before I told you a square root has both a positive and a negative value. So I could take, we did the square root of 49 is 7, because 7 times 7 is 49. But it can also be negative 7, because negative 7 times a negative 7 would give you a positive 49. So both of those are the two square roots of 49. And again, you can check yourself. Well, we know negative 7 is positive. So those are our two square roots. Example 2, finding square roots. Let's find the square root of 25. This is just a positive square root, so I just want my one answer. So it would be 5. Now these are perfect square roots. Okay, this is why I'm having you write all the squares and square roots so that you just have that list there so it can become automatic. Square roots like 16 and 25, maybe even 49, those are simple. It might be mental math for you. But if we get higher and I ask you for the square root of 169, that's another perfect square. You'll automatically maybe look at your list if you don't already have it memorized and say, oh, that's 13. Okay? Let's look at example B. I have the negative square root of 9/16. When there's a fraction underneath your radical sign there, you're allowed to break up the square root to the numerator and the denominator. So I can rewrite it so that it's the square root of 9 over the square root of 16. Because I know the square root of 9 and I know the square root of 16 individually. They're perfect squares. So the square root of 9 is 3. The square root of 16 is 4. So my answer is negative 3/4. And my last one is positive and negative square root of 2.25. This is a decimal. It's a little trickier. First thing I would tell you is to change it into a fraction. Let's see if maybe we can replicate and do something like we did in part B. So 2.25 would be 2 and 25 over 100, which simplifies to 2 and 1/4. Now we can't take the square root of a mixed number, so let's change it to an improper fraction. I get 9/4. So now I'm taking the square root of 9, the square root of 4. And those are perfect squares. Square root of 9 is 3. Square root of 4 is 2. So positive and negative 3/2. Maybe you want to change it to a mixed number. Maybe you even want to change it to a decimal. I would accept all of those answers. All right, we have a few more examples on our next page. Yeah. So let's slide over. Let's do a few more. We have example 3 here. What if we're evaluating each expression? Remember, evaluating means to solve. So again, using our orders of operations to help us solve this. First one, we do want to get rid of our square roots first. It's almost like our exponents. So do those first. Square root of 36 is 6. Now we do our multiplying. Now we add to get 37. Part B, I know if I break up this square root of 18 is not a perfect square. Neither is the square root of 2. So I can't do that method that we did before, but maybe there's another method. Can I simplify 18 over 2? Well, yeah, 18 divided by 2 is 9. Is 9 a perfect square? Yeah. So now take the square root of 9 and now just add. I get 3 and 1/4. Keep it as a fraction, change it to a decimal, whatever is easiest for you. And our last example, I have the square root of 81 and then we're squaring that. So you could do your parentheses. Square root of 81 is 9, but then 9 squared is 81. Anyone notice what just happened? When we square and take the square root of a number, remember those are inverse operations, so they really just cancel each other out, and you're just left with what's underneath the radical sign. So I'm left with 81. Okay, you could either have done those 2 steps or just automatically know that that's what I'm left with. And now I still have my minus 5 to do. So 81 minus 5 gives me 76. All right, so example 4 is a little tedious for us to go through just through a video. If we were in the classroom, I would be able to easily explain it and be there to help you. But since we're learning at home, I don't want to frustrate you or confuse you.